Welcome to this Teams IT Pro Academy session, Media and Microsoft Teams, Why Meetings Are Simple. My name is Martin Rinas. I'm a Senior Program Manager in the product group with Microsoft. Before we go into the content, let's do a little bit of housekeeping. You'll find this deck and the PowerPoint on AKMS/Teams Academy. If you would like to provide feedback on this session, please go to AKMS/Teams Community and add the IT Pro Training tag so that we can follow your feedback. For feedback about Teams features we're talking about in this session, please go to AKMS/Teams Feedback and either vote on existing feedback items or create a new one. Teams and Office 365 evolve constantly. So it might be that the service that you're receiving already has improvements that are not shown in this recording. Please always go back to AKMS/Teams blog to learn about the latest content here. At the end of this session, you should have learned two things. Meetings aren't complex anymore. They will simply work. There's not much preparation you actually would need to do. If you want to optimize for a more optimal media connectivity, it's as simple as implementing a rule for 2 IP subnets and 40 UDP ports when it comes for Teams. Exchange Online, Skype for Business have their own set of small optimization rules following the same concept. In this session, I'll be focusing primarily on Teams. When I was preparing for this session, I found this picture of this young lady wearing a rocket on her back, and I thought that's a nice visual for the session here. Why is that? Well, because meetings are simple. Meetings aren't rocket science anymore. Meetings just work. All you need to join a Teams meeting is a link. You can invite your customers, your partners, your employees. Everybody can be invited into a Teams meeting, and all they need to join the meeting is the link. There is no account required. They can download the client, but they can also just join through a modern web browser. There's really not much more. Obviously, there is a lot of rocket science when it comes to meetings, but the rocket science is not on you as a customer or as a partner, but the rocket science is on us, and we've listened to all the feedback that we've captured from talking to customers, executives, how we can improve experiences, and what we can do in our products to make your life simpler and easier. Common feedback themes we have heard from people that are using all kinds of meeting solutions in the past is that in the end everybody's interested that meetings just work. You need to be able to join quickly. You don't want to have to wait and install plugins or client software or anything. You're on a mission. You want to meet somebody. You want to talk about something, and you really just want this thing to work. Typical issues we have heard is, that joining a meeting takes too long, a couple of seconds, maybe even more before you are connected into the meeting. It takes a while before audio and or video connects. It may take a while before sharing is there. We keep hearing that people are dissatisfied because they are dropping out of meetings. It's not reliable. When you're on the go, maybe you have to dial in over PSTN or regular phone network to be able to be connected, because you can't rely on IP connectivity, and all those things are, is feedback that we heard loud and clear from our customers and from customers that are using different solutions. And we embraced this feedback and put a lot of effort in the Teams Media Stack to make sure that we get down to this. It's simple. All you need is a link concept. And I think we made pretty good progress here, and we have a pretty solid solution that helps you to achieve this. But then, seeing is believing. I mean, I can talk all day long about how great our product is and what are the cool things that we have done. But of course, everybody would do this. So let's jump in and do a couple of demos here that I've prepared for you to see what the actual improvements are and how you can benefit from them. The first scenario is the echo chamber. You know, you might be familiar with this type of concept or with this scenario. There's a meeting room like we see it here in the picture. People have started the meeting already from the meeting console, from the meeting system in that room. Somebody else might be a little bit late. That person, has his laptop with him, is entering the room and wants to join that meeting as well. Now, the reason why he brought this laptop, maybe he has content that he wanted to share, and now he's entering the room and is trying to join that meeting. So I'm the person that wants to join that meeting. I stepped into the conference room with my laptop open. The reason why I bring my laptop with me is that I wanted to share content, and instead of plugging in cables in the room, I decided to join the meeting, in the room as well as from my computer, so that I can easily do content sharing into the meeting from my computer. So what will happen is I will be hitting the join meeting button. I will be entering what we call the pre-join meeting screen. And what we see here is that Teams detects that another conference room has already joined that meeting. And during the pre-join experience, it will offer me to join with audio off to proactively prevent the howling and feedback that we otherwise might experience. So I'm joining with audio off. You can see that the microphone toggle is now turned off, and I can join the meeting without any howling. Now, that is great if I'm stepping in a big room that has a Microsoft Teams rooms in there, so that this system can be detected. But what about a scenario where I might be using a smaller focus room, and where there's no conference room equipment, no MTR deployed, but maybe just USB devices that I can plug into my own device. We have built in howling detection and suppression into Teams as well. Let's see how that works. So again, I will be joining the meeting. And I think we've all been in this situation where we, all of a sudden get this feedback loop, this howling, and we need to, everybody in the room is getting hectic and needs to figure out, okay, who's causing the echo? Do we need to turn off my microphone? Do we need to turn off the speaker? What I need to do to stop this howling and this noise? What Teams will do is, it detects this and offers you a user-facing diagnostic at the top that we can see right now, which will then, do the right things and turn off the audio so that you're relieved from this, painful situation and continue with this meeting with ease. Another common scenario is that we have situations where network conditions aren't as optimal as we would like it to be. The world is changing. People are more mobile. Specifically on the mobile network, we always can't rely on having enough bandwidth available. So we made big investments here in improving the codecs, and this change is in the process of being rolled out. So the setup here is that in this slide, in this demo, we will have two sections of an audio sample. The first one is without the improvements. under bandwidth constrained situation. So we're doing an audio stream over 7 kbps, which is really not a lot of bandwidth, which we might see if we're on a not so well connected mobile network, something like that. We'll see this, the first section of the audio is without the improvements. And then the second sample that we'll see here right after that is the same audio sample, but using the improvements under the same challenging network conditions. So let's see, or let's hear how that works out.
The coffee stand is too high for the couch. The coffee stand is too high for the couch.
The set of china hit the floor with a crash. The set of china hit the floor with a crash.
The ship was torn apart on the sharp reef. The ship was torn apart on the sharp reef.
So it's clearly obvious that there's a big difference in audio quality, and that we will be able to deliver crystal clear audio in ultra low bandwidth conditions. So this really helps in scenarios where the connectivity isn't as good, and maybe we're on the go, we are mobile, and this feature allows us to join Teams meetings even on poor network conditions with ease, join through mobile, through VoIP, so that we don't have to do the fallback into PSTN. Another common scenario is, again, for mobile scenarios, when I'm on a Wi-Fi, that we're having what we call burst loss. Codecs in the past were able to keep up with average packet loss, uniform packet loss over some time. We're able to deal with that pretty well. The challenge has always been to deal with burst packet loss. So if we're losing a large amount of packets within a very short time frame, this has been a challenge in the past. Scenario here typically is maybe I'm roaming with my device, inside the building. And my device is connecting from one wireless antenna to another wireless antenna. Could be Wi-Fi. The same applies if I'm on a mobile phone and I'm connecting from one mobile antenna to another, or any other situation where all of a sudden we are losing a lot of packets in a short time frame. Again, we have two audio samples here, and this should be pretty familiar to a lot of you. The first example again is 30% burst loss, a lot of burst loss happening, experience that what it was used to be. And then the second example is with improvements in the codec and an actual new codec and other improvements to illustrate how we are able to run, deliver a really good audio experience even under those challenging network conditions.
Statistical mechanics is the birthplace of entropy and law of dynamics. Entropy always increases. Among other things, the second law allows to dismiss claims perpetual motion machines. Statistical mechanics is the birthplace of entropy and the second law of thermodynamics. Entropy always increases. Among other things, the second law allows one to dismiss any claims to perpetual motion machines.
So I think this is a quite impressive demonstration, because it really shows how we are able to deliver a really good audio quality even under very challenging network conditions. And that is something that I've experienced myself quite a lot when I'm on the go, joining a conference call from my car while driving somewhere. It's really good to see how Teams is being able to keep me connected and deliver super audio quality. And so I was able to listen into the conference calls while I was on the go. Another common scenario is that we're seeing that the people we are working with and the way how they behave are changing over time. So while we know, and we would love and recommend that everybody is using a certified headset to get the most optimal audio quality because of all the hardware improvements and the hardware processing that is happening in certified audio devices with headsets certified headsets most of the times have, multiple microphones to do background and ambient noise suppression, and all of this is done in hardware. We also have to realize that the environment is changing, and people start working a lot, in settings like this in public spaces, and nobody of them is using an audio device and a certified headset or anything like that, but they're all using computer audio, mic, and speakers, which is somewhat challenging because in those environments there is a lot of background noise, a lot of ambient noise in open spaces, coffee places, etc. And we can't rely on the hardware doing the background noise suppression because there is no hardware support to do this. We invested in that scenario and made sure that we are able to detect the background noise while we are not using a certified audio device, and applying background noise suppression in those scenarios. So again, setup is the same. The first example is how it used to be. And then the second example is with the new improvements turned on, how we're able to reduce the background noise here. So there's a lot of things that we have done in the service, in the team service, in the client, as well as in the media stack to deliver all of those capabilities that are in the process of being rolled out right now. Now the question is there anything that our customers that you can do to further optimize the quality? Yes, there are things you can do. If audio quality is super important, there are certain things that you actually can do to improve the audio quality even more. When I talk to customers, sometimes I get feedback that, or the impression that people think that connecting to a service, to our service, Office 365 and Microsoft Teams, and at a network layer looks a little bit like this. On the one side, with the corporate network, where corporate environments have full control and full responsibility over the connections, and then they are connecting to the internet and using the internet to connect to the service. And at the internet, we have only limited control. We can select the ISP. Usually, we might have a little bit higher bandwidth, but we don't have end-to-end quality of service or guaranteed delivery or anything like that, which we get from a managed network. But the reality is that this is not actually quite true when we're talking about Office 365 and Azure, because Microsoft, we did massive investments in our own network, which you can see here on the right side, the Microsoft network, the green arrow on the right side. So with this network, we are under control what's happening inside here, and so we are only using the internet to connect to our service for a very short amount. Then you would be entering our own network, and from there on, we are under control, and we can make sure, and we will ensure that there is no jitter or packet loss being added, that latency is only imposed by the speed of light and distance, and a couple of other things that we are doing here to make sure that you get the best experience. So let's talk about this for a little bit more and expand on this concept. What we see here is an illustration, a conceptual illustration on the size of our network. So it's really a global network. We have peerings in more than 190 locations with more than 2,700 ISPs. So this network is really a global network, very well connected. Not only that, we have 45 and more data centers. We also have more than 100 locations where the Azure front door locations. We'll talk about this in a second as well. If you want to learn more about this network, here's the link, akms/Microsoft-network. If you want to learn more about this, please go there and read up on the network. One fun effect that I'd always like to share is just to illustrate the scale of this network and why it's why I personally feel quite good about this and the advantages that we bring to our customers. Quite a while ago, we had to realize that the connectivity between Europe and North America and the subsea cables, that capacity there was maybe not necessarily reaching the limit, but capacity wasn't available to that extent, with the projected growth that we were expecting. And there was no capacity available that we could use. So what we ended up doing is that we entered a joint venture with Facebook and a global telecommunications infrastructure company. And together we installed a subsea cable between Europe and North America, adding a total of 160 terabit per second of capacity to those networks. So there's a lot that we are doing here to make sure that we have the best possible experience for our customers. What's the advantage? Why is it important to leverage as much as possible from our network? It's not just about because our network, might be performing better than the network of anybody else. That's not really the point here. While it might or might not be true, that's really not the key thing here. It's more about the fact that entering our network allows us to use certain scenarios and certain features and capabilities to make sure that we reduce the latency as much as possible. Why is that important? Well, in a software as a service world, latency is really the currency. You want to make sure that we keep the latency as short as possible, and the latency is really about the end user and the connection point to the service. That is the latency that has a massive impact on the end user's experience of that service. It's not necessarily about where the data is located, because data protection is super important to us. So if you have a, let's say, European tenant and you don't configure anything else, like Office 365 multi-geo, all your data is stored in Europe. It will only be stored there. That's for sure. Nevertheless, there are certain components that we can deploy on a global basis to make sure that we reduce the latency between the user and the service endpoint. And this is what we call AFD, the Azure Front Door. So conceptually, for Exchange, think of this as the Café server, SharePoint Online. Maybe think of it conceptually as the web server. And for Teams, we have components as well, which are called the transport relays and media processors, which are, without going too deep into this one, which are the endpoints for your media connections. And what we can do here is we can bring those endpoints closer to the user within our network, so that the latency between the user and the service is being reduced, while the tenant's data is still in its home tenant location. But allowing this is really there. Using this concept allows us to reduce the latency and then have a great impact here. And now I think it's important to understand what you can do to use these investments that we made to make sure that you get the most out of it. So let's talk about this. What you can do and what we recommend you to do is to detect Office 365 traffic. Specifically, we have the concept of endpoint categories here. Detect traffic that is most impactful to the end users, and treat this differently than any other Office 365 or traffic to the quote unquote random internet. We would recommend you to detect traffic to the Office 365 optimized category and break this out locally, as local to the user as reasonably possible. Send this off to the internet so that you can leverage our global network and all the infrastructure that we put in place as quickly as possible, while all the other traffic to the internet, etc., can be backhauled and put through your security stack for a very good reason, because there are threats on the internet you need to protect yourself from. So that's perfectly fine. but really want to make sure that you can optimize your network for the trusted service of Office 365. This is certainly important for your offices, but also consider connections like your client VPNs, and make sure that you apply the same optimizations here if you want to further improve the user experience here. Technologies like SD-WAN, software-defined networking, are great enablers here, and we have the required APIs, to allow you to do this in an easy way. So, what can you do if you want to optimize traffic for Teams in particular? Well, it's as simple as this table shows here. The optimized category for Skype Online and Teams consists of 2 IP address ranges and 4 UDP ports. And those endpoints in the optimized category are very static. You should not expect a high rate of change. The opposite is the way. If we are going to introduce change, we might be removing endpoints here, but it's very, very, very unlikely that you will see us adding new endpoints into this category. So if you want to optimize for a really high quality Teams meeting experience, all you would need to do is implement local internet breakout for those 2 IP address ranges and 4 UDP ports. Side note here, as I said earlier, the same concept applies to Exchange Online and SharePoint and OneDrive for Business. They have their own very small set of optimized endpoints, which should follow the same concept here. But for Teams, it's really just these 2 IP address ranges and 4 UDP ports. These 2 IP address ranges are service exclusive. So endpoints in these IP address ranges will only be used by Skype for Business Online and or Teams. So there is no other service or component inside these IP address ranges. So going back to this picture, what we've just done is, by implementing the local internet breakout, is we've reduced the amount of corporate network that is involved. The amount of internet that is involved, might or might not change, but in the end, you can take more advantage of the Microsoft network and all the improvement that we are doing in the service with bringing the service endpoints as close to our users as technically possible. So this is really the recommendation here. Implement local breakout for Office 365 traffic, while all other traffic is still routed to your centralized security stack. So as a recap, what are the key concepts we just talked about? Teams meetings aren't complex. It doesn't require a lot of network engineering ahead of time to get those up and running. We have spent a lot of time and effort in the Teams media stack and put all the rocket science is on us. We took a lot of effort on optimizing the Teams media stack for that. If there is a need to optimize, it's as simple as implementing those the local breakout for 2 subnets and 4 UDP ports, so that you can leverage the service-specific endpoints here. Also, a complex network assessment might not be required prior to onboarding. It might be required that you do additional improvements on that, but I wouldn't necessarily gate the onboarding to Teams meetings with a big network assessment. Start using Teams meetings today. It's as simple as joining, receiving the link, opening the meeting in a browser, and you will be connected to the meeting. A couple of session resources here. If you want to learn more about connectivity to Office 365, the principles, and do a deep dive into that one, I highly recommend this first link here, aka.ms/BRK3000, which will bring you to a session held at the Ignite conference 2018. A great session explaining all the concepts in Office connectivity, the endpoints, strategies, how to go about this in very great detail. So that's highly recommended. The second link, AKMS/PNC, Principles of Network Connectivity, is essentially a write-up and the ongoing documentation from the session above that I mentioned above. So this is your go-to place if you want to read up on all those principles. We have a couple of links here for Teams documentation if you want to learn more about how to prepare, as well as the link to the Microsoft Network. And last but not least, AKAMS/O365 endpoints, which is your go-to place for the latest information about endpoints that you need to consider when connecting to a service in Office 365.